So another example from the op amp is when we have a non-infinite gain. So if we have gain is equal to 100,000 volts per volt, what are all the currents and voltages in this amplifier? And we could have a reference voltage instead of ground on the non-inverting input, but it doesn't really show anything different. The main thing I want to show is what is that voltage on V minus and how does the response of this system change. So again, we have I minus equals I plus. That's the currents going into the op amp, this current here and this current here. And again, those are equal to 0. This is a not ideal op amp from the standpoint that it has a non-ideal gain, but we're still assuming that it's essentially an op amp from other aspects. It has 0 output resistance and infinite input resistance. And if this was a real BJT op amp, then that actually wouldn't be true. But it wouldn't make things too much more difficult anyway. So again, that vertical or that virtual short exists between the non-inverting and the inverting input, so that the non-inverting input shows up on the inverting input. So V2 is equal to V plus, which is equal to 0 volts in this case. And we know that V out is A times VID, and that equals A times V plus minus V minus, or V2 minus V1. And V minus is equal to, oops, wrong way. V plus, or V2, is equal to 0. So we could really just say that V out is equal to A times V minus. And that equals 100,000 times V minus. That's what the negative feedback is trying to make. Now, the easiest way to solve this, since we have a ideal non-infinite gain, is to use equation 2.5 from the book. And that gives us an overall gain of G V out over Vn is equal to minus R2 over R1. I have to say what values R2 and R1 have here. It's the same as what I had before. 50K and 100, or 1K, I think is what I've got. So R2 over R1 over 1 plus R2 over 1 divided by that gain. I got that enlarged too much. So, and of course, if that's infinite, then this just reduces to the non-inverting configuration of minus R2 over R1. But that's not what we have. We've got a non-finite gain. So then we could substitute in numbers. And we've got minus 50 over 1 over 1 plus 50 over 1 divided by 100,000. So the ideal gain in this case would just be 50, right? 50 over 1. Now we get minus 49.975 volts per volt. Pretty close to 50, but it's not quite 50. And that means it'll cause a few changes. So if we have Vn is equal to 1 millivolt, then V out is G times V in. And of course, so again, a V plus is 0. So this statement here is still true, that A times VID is what we're really amplifying, but now we have A times V minus. So this would be, sorry, I should, let's see, I want to say it's, well, no, that's a little bit confusing thing. So I'll just stick with this. V out is G times V in, and V in is 1 millivolt. So I'm not talking about what I just circled up there. I'm not talking about that. I'm talking about the overall gain of the amplifier. And so that's minus 49.975 times 0.001. And that gets us minus 49.975 millivolts. Ideally, it would be 50 millivolts. We've got just a little bit less than that. So now we could find that load current, IL, and IL is going to be that voltage, 0.04975 volts divided by the resistance, and I think I'm saying RL is 2K ohm. So divided by 2,000, that's equal to the minus 24.987 microamps. And we could now find the value of V minus, because V out is equal to A times V minus. If it was ideal, it would be exactly 0, but it's not. It's awfully close though. So we can solve for V minus. That's V out over A, because these are the two things we know, right? We know those two things. So we could solve for V minus, and that would be minus 49.975 times 0.001. I could have put in the output value, divided by 100,000. And that equals 499.75 nanovolts, e to the minus 9 volts, or 0.5 microvolts. And we can find the current, I1, that's that one going into there. I1 will be the difference between Vn and V minus over R1. So that's 0.001 minus 0.5 e to the minus 6, half a microamp, divided by 1,000. And that gets us 999.5 e to the minus 9 amps, which is pretty close to 1 microamp. And that's just about, and that's what we would get if we had a infinite gain. And I out that's the output of the op amp itself, right? That's not what's going into the load. It's not I2. This is what the op amp is actually needing to output. So we can find that. I out is IL minus I2 by KCL. So that'd be 24.987 microamps minus 999.5 minus 9 amps, which is equal to 23.989 microamps, which would be very close to the ideal value. I won't, I'm not thinking right now to give my open math problem. If one shows up at the end of this video, then there is one. Otherwise, I just wanted to work through that and show you that. The crux of of solving something like this is to use this equation 2.5. That's what will help you solve it.